In the dark expanse of the cosmos, hiding in the constellation of Cancer, there's a treasure that's almost impossible to wrap your head around. It's a world that makes all the money on Earth look like pocket change. And we're not talking about gold or oil. We're talking about the ultimate prize. Just 41 light-years from us sits a planet with an estimated value of $26.9 nonillion. That's a 26 with 30 zeros after it. This isn't some ordinary world of rock and ice. Early theories suggested that this planet, 55 Cancri E, is a super-Earth made of graphite and a thick layer of pure, solid diamond. It's a cosmic vault holding a treasure so huge it's hard to even imagine. So what would it take to pull off the greatest heist in human history? What would it take to claim this trillion-dollar planet for ourselves? Well, the answer takes us on a journey into a cosmic furnace, a hellscape that would push our ambition, our technology, and our very understanding of the universe to its absolute limit. This is the story of the Diamond Planet and the impossible cosmic heist. Okay, so for any good heist, you need a profile of your target. Ours is named 55 Cancri E, also known as Janssen. It was first spotted back in 2004, not by seeing it directly, but by the tiny gravitational tug it has on its star. A team of astronomers noticed a little wobble in the star 55 Cancri E and figured out there had to be a fifth planet there, and it just so happened to be the first super-Earth ever found orbiting a sun-like star. And this isn't some lonely rock. 55 Cancri E is in a busy solar system with at least 4 other planets, all orbiting a star you can actually see from Earth with your naked eye if you're in a really dark spot. That gives this alien world a strange sense of being right next door, as if it's hiding in plain sight. The planet itself is a beast. It's about twice as wide as Earth, but weighs in at nearly 8 times the mass. This incredible density was the first clue that something very strange was going on here. It whips around its star in less than 18 hours. A whole year on 55 Cancri E is shorter than one of our days. This insane speed means it's incredibly close to its star, about 25 times closer than Mercury is to our Sun. And that closeness is the key to understanding both its incredible treasure and the terrifying security system that's guarding it. So where did this wild idea of a diamond planet even come from? It wasn't just a random guess. It was based on some fascinating cosmic chemistry. You see, planets are built from whatever materials are floating around their star. The makeup of a star can tell you a lot about the planets that grew up alongside it. The original theory from a team at Yale was that the host star, 55 Cancri E, was super rich in carbon. Think of elements as building blocks. In our solar system, oxygen is a way more common block than carbon, so our planets are mostly silicate-based, that is, made of oxygen-rich rocks. But what if a solar system had more carbon blocks than oxygen ones? The planets it would build would be totally different. In a carbon-rich system, 55 Cancri E would have formed with a ton of carbon. And what happens when you put carbon under crushing pressure? It turns into diamond. Scientists figured that deep below a surface of graphite, the same stuff in your pencil, there was a thick mantle of pure diamond, a layer of gems so huge it could make up a third of the planet's entire mass. Imagine a world with a diamond core thousands of miles thick. This wasn't a planet with diamonds. The planet was the diamond. This was the prize. But like any treasure this big, the vault is practically impossible to crack. And this is where the plan hits a wall, a giant, flaming wall. The very conditions that could create a diamond planet also create one of the most hostile places in the known universe. 55 Cancri E isn't just a planet, it's a furnace. Because it's so close to its star, it's tidally locked, meaning one side is forever cooking in the star's glare while the other is stuck in permanent darkness. Let's start with the hot side. The dayside temperature was once thought to hit a staggering 2,700 degrees Celsius, or almost 4,900 degrees Fahrenheit. That's hot enough to melt any metal we know of, turning the surface into a bubbling global ocean of lava. The pressure is immense, the gravity crushing. Any ship we could build today would be vaporized and squeezed into dust before it even got close. The night side isn't much better. While it's cooler, it's still a horrifying 1,100 degrees Celsius. The temperature difference between the two sides is so wild that some models suggested there might not be a stable atmosphere to spread the heat around. Instead, you get a two-faced world. One side is a searing lava ocean, and the other is a solid but still scorching rock. More recent ideas suggest that the rock itself might vaporize on the hot side, creating a thin atmosphere of minerals, which then condenses and rains back down as molten lava on the other side. You can't crack this vault. It's a planetary inferno. But even if you could somehow build a ship that wouldn't instantly vaporize, the heist has an even bigger problem: distance. 55 Cancri E is 41 light-years away. That doesn't sound like a huge number, but the scale is just mind-bending. 1 light-year is about 9.5 trillion kilometers, or 6 trillion miles. So we're talking about a 390 trillion kilometer trip. To put that in perspective, the fastest thing humanity has ever launched is NASA's Parker Solar Probe. If we aimed it straight at 55 Cancri E, it would take about 68,000 years to get there. The round trip to bring back the goods would be 136,000 years. That's a time frame that makes all of recorded human history look like a weekend. The universe has the ultimate security system: distance. The heist is over before it even starts. But this is where the story gets really interesting, shifting from a treasure hunt to a complex scientific mystery. The Diamond Planet idea was a brilliant piece of science, but science is all about changing your mind when new evidence comes along. Newer studies started to poke holes in the theory. One group rechecked the star and found it might not be so carbon-heavy after all, with about 25% more oxygen than carbon. That discovery threw some serious shade on the whole Diamond Planet idea. The biggest plot twist, though, came from the most powerful space telescope ever built, the James Webb Space Telescope. In 2024, by looking at the planet's infrared light, scientists found something amazing. The planet's day side was only about 1,500 degrees Celsius, way cooler than the 2,200 degrees they expected from a bare, airless rock. That temperature gap is the smoking gun for an atmosphere. Webb's data suggests 55 Cancri E is covered in a thick atmosphere, probably full of carbon monoxide or carbon dioxide. This isn't the atmosphere the planet was born with. That would have been blasted away by its star ages ago. Instead, scientists think this is a secondary atmosphere, one that's constantly being refilled by gases bubbling right out of that planet-wide magma ocean. The planet is literally burping up its own atmosphere from its molten guts. This constant change in our understanding is what makes science so exciting. We start with a wild idea like a diamond planet, and with new tech and hard work, we uncover a reality that's even weirder and more complex. If you find these cosmic puzzles as cool as I do, make sure to like this video and subscribe for more journeys into the unknown. So, is 55 Cancri E the trillion-dollar diamond planet? The latest evidence says, probably not. The story changed. The simple tale of a cosmic treasure chest has been replaced by the much cooler reality of a volcanic hell world, wrapped in an atmosphere that's seeping out of its own molten surface. But in a way, that makes the planet even more valuable, not in dollars, but in knowledge. We can't go there. We can't mine it. But by studying it from 41 light-years away, we learn about the incredible variety of worlds out there. 55 Cancri E is a unique lab for understanding how the atmospheres, surfaces, and insides of rocky planets work. It gives us a peek into the chaotic, fiery childhoods of planets like Earth, Venus, and Mars, which were all likely covered in magma oceans billions of years ago. The real treasure of 55 Cancri E isn't diamonds. It's the knowledge that helps us piece together the grand cosmic story of how planets, and maybe even life, come to be.